Am I sharing this in?
Oh,
I don't see that in my screen. So, okay.
yes.
Yes, I'm trying
Oh,
to.
in the comments tab and it's literally left down. Oh, it's coming from another.
Yeah, I don't see that dialogue in my screen. So,
Oh,
Maybe with question below.
oh yeah,
maybe. You mean this one? No, this one.
I think so.
No, I don't think so. Okay, stop share.
Okay.
Very Counterintuitive interfaces. Okay.
Can you stay close to the computer so that it can just close? Not maybe like not all the way there, but maybe like we don't have,
Sure. So, welcome everybody on a Saturday this morning, being here. Thank you. I'm going to talk a little bit about big data for social good and mobile phone data for migration and mobility. I have been working with mobile phone data since quite some time. One of my master's students, Didam, decided to do her master's thesis on mobile data. At that time, there was a data challenge in Ivory Coast. The government worked with the telco to recreate the country after the civil war, and they shared a lot of data from the country, from telco of the country, with researchers saying, do whatever you can, we want to rebuild this country. And Didan was very enthusiastic. I had no idea about the topic. She came to me and she said, I want to do a thesis project on this. And if you know, in Turkish universities, of course, we have small numbers of faculty members. We were, I think, 15 people at the time at my department in bilgisayar mühendisliği, computer science, computer engineering in the North Campus here. I said, yes, sure. Let's do our best. You do the work. I'll try to supervise you as much as I can. And that eventually turned into the Data for Refugees Challenge, because in 2015, when there were 2.5 million Syrian refugees in Turkey, we had a meeting here in South Campus with TÜBİTAK. We were trying to think about what can we do for the refugees? How can we help them? And somebody from TÜBİTAK said, well, the Türk Telecom also wants to do something. And I said, well, they can give us data because nobody knows where the refugees are. So that turned into the big Data for Refugees Challenge. I'm going to talk about that as well. But my group at Utrecht University, we mainly work on computer analysis of human behavior. So if you ask me what it is, basically you sense the human behavior with some sensors, whatever they are. Then you do some sort of analysis, and then you plug this into applications. Now, if you want to do social good, if you want to do computational social science, then the applications are still very broad. You can basically think of anything that will help the society in some way, and you can do that. But of course, sensing, you can measure the real world behavior of people. You can, for example, put a camera here, look at the class, and see whether the students are interested or completely bored out of their minds with a camera. You can use a microphone, you can analyze my voice and determine that I was in a concert yesterday. But you can also use the mobile phones. Every mobile phone, how many of you carry a mobile phone with you? I think everyone almost, right? Well, it's a package of sensors, right? It has at least 16 sensors that I know of, maybe even more. So it's recording a lot of information about you. So we can use that data, if we have access to it, to learn things about you. But everything you leave on the internet, when you browse the internet, you leave digital breadcrumbs. Every time you log into a massive multiplayer online game, we learn things about you. Every time you log into social media, how many of you are on X, for example? Let me see. Blue Sky? Any Blue Sky takers? Any other social media channels that you use? Instagram? Yes. I think it's the biggest social media in Turkey now. Yeah. So there is a lot of data people are collecting about you. Your mobile phone company knows whether you are a good Muslim and attend the Friday prayers at mosque, or you're a good Jew and you go to a synagogue on Saturday, or a Christian to go on mass on Sundays. Everything you do is recorded. Okay, so we get the data, then we analyze it. There are a lot of theories in psychology, sociology, depending on what is your resolution of looking at human behavior. You're looking at a single human or at two humans, you look at psychology. If you look at 1,000 or 1,000,000 humans, you look at sociology or your resolution. If you don't know anything about it, like me, then you go to pattern recognition and machine learning. You try to ask the data, okay, what kind of patterns are there, right? So I'm going to show you some results from the mobile phone data in Turkey. There we work with sociologists because we have no clue about what the patterns mean. So the sociologists tell us, oh, that's an interesting pattern. That's not a real pattern, you know. Then you have a lot of applications, and these are just exploding at the moment. When I started working on this problem in 2010, we didn't have large language models. We didn't have the deep learning explosion, and the models were still struggling a lot to understand human behavior. Right? So that's still a ongoing process. Now, in my group, we look at individual behaviors. I'm not going to talk about them. We look at speech recognition, action recognition, facial expressions, mental health diagnostics, for example, depression detection from your face, from your social media posts, etc. We look at dyadic and group behaviors, turn taking, mimicry, rapport, whether a psychotherapist and a patient have a good alliance, working alliance. We look at that. We look at playful interactions. When a parent plays with a 2-year-old kid, can we guess whether the kid will develop problems later in life from this interaction only, right? So these are interesting problems. And in Utrecht University, we have this data set collected over 16 years. They followed 4,000 families from pregnancy to adolescence. Huge data set, 20 million euro project. It was finished when I went there, but we can access the data. You can access the data if you want. So we look at child-parent interaction. And at the most upper level, we'll do computational social science. We look at migration and mobility mainly from mobile phone data. Now, in this area, you will have two challenges. One of them is a technical challenge. You want to measure something, the data is noisy, there are gaps. You're going to have a lot of problem creating algorithms that will work for you. But there's also a human challenge. You are trying to think about the social implications and ethical considerations about the algorithms that you develop. So imagine you being, 10 years ago, somebody, a computer scientist, was working on algorithm in Twitter, recommender algorithm. So which posts shall I augment, show to my user? Which posts shall I hide, right? Simple problem. Now, that person probably did never have an ethics course in their life, didn't know anything about sociology or politics, and had no clue that the algorithm they introduced would be a massive boost to the far right in the world, deepening the echo chambers, social cracks massively. Why? Because our algorithms, when they are out in the world, they change the society. And small things have big effects. And it's very difficult to, in hindsight, we can look at it and say, obviously this algorithm will promote people to just see things that are similar to their ideas, and it will create these echo chambers. We had no clue, right? This was all discovered later on. Now, one good framework to look at whatever you're developing is the SDGs, United Nations Sustainable Development Goals. How many of you are aware of the 17 SDGs? Oh, excellent. So when I do this presentation in my own class, I don't see any hands raised, right? So very few people. But you, of course, are much better positioned and you know about this framework. It's very good. These goals are unattainable almost, right? We're not going to reach them by 2030. That's not going to happen. But working towards them is very, very worthy. And we want to do things. For Turkey, peace, justice, and strong institutions is super important. And my colleagues here in Boğaziçi University are trying to uphold this, trying to protect their institution. I have tremendous respect for that. Leave no one behind is very important for my own work. We want to do things for refugees. We want to make sure that they get a decent life. It's important. Now, this was a report in 2018. McKinsey Global Institute, an important institute, does these global reports, a consulting firm, looked at how many AI applications do we have for social good, and they found quite a few of them, especially in health and hunger, a lot of them, infrastructure, public and social sector, security, justice, crisis response. So when you have an earthquake, when you have a flooding, when you have a tsunami, there's a lot of effort that needs to be coordinated. So there are AI applications, which makes sense because artificial intelligence from its birth, maybe you know this, maybe you don't, has been always funded by primarily the US defense, right? DARPA funded early AI research. And when US had an operation in Afghanistan, the Minister of Defense said, all the money we have spent for AI so far, we got it back. Because this was a massive deployment task, and all the optimization algorithms that we have developed so far paid off, and they were able to have this huge operation. But of course, you don't have to do this for the military. There are many other applications that we can actually push for. Now, this report has been recently renewed in 2024. Now we have more than 600 cases of AI for social good, and especially for good health and well-being, because a large portion of the world does not have access to doctors, does not have access to psychologists and psychiatrists. So if you look at mental health care, 1 billion people in the global south have no access to psychotherapy. So can we create chatbots that will help you with your depression, for example, right? There are a lot of applications. Now, okay, so Anna Bethke from Intel made a kind of list to tell you what do we need to apply artificial intelligence for social good. Well, she said, well, you first need a problem to solve. Where do you start from? Maybe you are from a sub-Saharan country where water is extremely precious and you want your villages to have water. That's a worthy goal. How do you use AI to help this goal? Now, there can be many, many problems. Endangered species, diagnosing tumors, helping refugees, whatever you want. You need a problem. Then you want partners to work together because that problem is probably being tackled by certain NGOs and IGOs, certain governmental organizations, even companies, right? You need them because they know what's at stake. They know the real parameters. Assumption is the mother of all problems. If you know Steven Seagal's movies, it's not another word they use in the movie, but fair enough. You really need to collaborate. You need data because without data, you're flying blind, right? Without data from the field, you're not going to be able to do much. And this is one of the things where we as computational social scientists make a difference. If you're working for a company, you can become a data steward and open your data to public partners, IGOs, NGOs, and help them solve a problem. We need computing power because when we create a solution that will require some computational resources, we're going to develop algorithms. We're going to test the system to see whether it actually works or not. And then we need to deploy it in the real world, which may have very different conditions than the lab conditions. A data collaborative is a cooperation between private and public sectors. So suppose you're Türk Telekom, you're sitting on the data of 25 million Turkish people. If you open this data to a public partner like Kızılay, for example, or the Red Cross of Turkey, they can optimize the positioning of mobile health centers because you know where the refugees are. They can actually cater for them. So how do you do that? That's very important. There are a lot of sources for private data. It's not just mobile phone companies. You have satellite images, social media content, wearables, smartwatches, infrastructure usage. So if you go to the Netherlands, for example, the Statistics Institute of Netherlands gets the data directly from the Dutch railways, and they know how many people are using the trains from traveling from one city to another every day. And that's super important because based on that, for example, you can manage the production of agricultural products, you can manage the energy infrastructure, you can create additional resources for schools, for example, right? If you know that a lot of people now are living in Utrecht and working in Amsterdam, maybe you can open a few more schools in Utrecht to cover this. Yeah. Any data trace on systems used by thousands of people is a potential source of data for us. Okay, I'm just going to talk about mobile phone data here. Is there anybody who has worked with one of these data sources so far? You have worked on social media and LLMs and many other things, satellite data as well. Satellite as well.
Infrastructure usage as well, pipeline, gas and oil pipeline.
Gas and oil pipeline. Where do you get the data from? Is it public?
Energy something like this.
So you contact a company to get the data from them.
It is, I think, open source by now, but I have to check. Let me check it.
I use online game. Online game.
Online games. Okay.
Constantly.
Okay. Steam. Steam is a huge platform. How many users does it have? Hundreds of millions, I'm sure.
More than hundreds of million,
Okay.
yeah.
Well, in my home, we have 2 Steam users. Me and my son. Yes, check it out. Social media. How many of you are using X, now the former Twitter? Wow, a lot of people. Any other source? Yes. Wearables. You use wearables? Fitbits. Okay.
Instagram and Facebook.
Instagram and Facebook, yeah. Okay, so you know that the potential of these platforms, you know the richness of the data. Anything that has a million and over a million users is bound to create a lot of useful data. But how do we do that, right? So mobile phone data is a bit special because we carry mobile phones around with us everywhere, and they are actually quite detailed. So there are a bunch of ways of getting the data. You can use an application on the mobile phone to get the data. So you say, oh, I want to use your data, install and use my application. Every time you use an application, you give a lot of permissions to the application owners. They might have access to your GPS location, for example, or they might have access to the Wi-Fi signals that you are seeing at any moment around you. Now, these are sensitive data points. They need to really justify it if they want to post their application on, let's say, Apple application store, but they can do that. Right? There is also a possibility of using an application on the phone to interact with a system. So, for example, if you're going to a supermarket in the Netherlands, your phone may have the application of the supermarket installed on it. And every time you enter the supermarket, it will interact with the local server, and the supermarket will know that you are in the supermarket at that moment. And every purchase you make, maybe it's stored in some thread that is special to you. So your supermarket knows whether you have a kid or not, because maybe you're buying Pampers for your kid or baby food. They know about it. Or depending on your purchases, they know your monthly income because you're constantly buying champagne and caviar. Maybe they do inference on that, right? We have worked a lot with mobile call detail records and extended data records. These are data records that you obtain directly from the telco. How many of you have ever worked with CDR here? Okay, no, all right, good. So the first large-scale applications of these mobile, yes, please. Call detail records. I'm going to give you an example in a bit. But not all mobile phone data is coming from CDR. So the first famous study was MIT reality mining study. Eagle and Pentland, this paper you might know. They gave Nokia smartphones at that moment, there were no smart screen type phones, so it was still a brick, the mobile phone. 2004, 2005, they gave the phone to 100 or 450 students and academics, and they recorded data for 150 days, something like that. The data is very simple. When the phone is on and off, when it is receiving a signal or not, and then the GPS location. But even with that information, they showed that so much can be learned about the user of the phone. For example, they were able to determine whether the owner was an economics student or a computer science student, whether a first year or a fourth year, because, fourth years were always in the lab doing nothing, just working. If it's a business school student, they were going and having fun. I don't know. So it was possible to determine from the entropy of the signals even what kind of signal we're doing. And that was kind of like a wake-up call. Your mobile phone knows so much about you. And then we had, many different data challenges and data sets collected from phone applications, from smartphones, etc., over the years. Now, we have worked on mobile phone data for analyzing displacements. Because you have the GPS location from the mobile phone or the base station location. So when you make a phone call, of course, your phone company knows to which base station this phone call is routed to. So they know your location practically up to a certain resolution. So how do we use that? Well, you can get this data from the telecom operators, from application owners, even from business to business companies. We work with DT1, which sells telco to telco credits. What does that mean? Well, suppose you are living in Turkey and you're making good money, but your parents live in Uganda. What you can do is you can send your mobile phone credits to them. You can top up their phones using your local Vodafone credits here. That's much cheaper than sending actual money to Uganda. Okay? So DT1 was providing this service, and there are some corridors, and I'm going to show you later a result that shows the distribution of Cameroonian migrants in Italy, which was much better than the official story, right? Because the Cameroonians are sending money to their parents in their home country. And even though the government doesn't know where they are, the phone company or the DT1 knows where they are. Anyway, so we acquired this mobile phone data. Now, this is super sensitive data. So you need to do the anonymization and aggregation so that people cannot be individually tracked in this data set. I'm going to show you a few things about how to do this. You may do group selection. For example, if you're looking at Syrian refugees in Turkey, you need the locals and the Syrians. So you need to divide the data into two groups. Then you get a bunch of indicators and features. And these can be things like, okay, you want to measure social integration of Syrian refugees in every town of Turkey. Maybe you need to detect how many phone calls are placed from Syrians to Syrians versus Turks. Or what are the places in a city where Syrians and Turks come together? Are there base stations in which we have mixed coverage? Or do we have segregation? Maybe there's an area in Turkey where it's attended only by Syrians. Maybe there's a refugee camp there. That means poor integration. So there are things you can create. There are features and indicators, individual spatial network plays. You can look at stocks and flows. So later today, I'm going to give you a data set that looks at origin destination matrices. So we have a country or a city. We have a grid, and I will give you a data set that shows us how many people move from one cell of the grid to another cell of the grid every day for 160 days. How can we predict the mobility of people with this kind of data? That's the question I will pose later. Anyway, we do analysis. Of course, we do statistical models, simulations, machine learning models. We can do forecasting. We can also do descriptive analysis. So earthquake happened in Turkey, in Hatay, Malatya. Can we see what happened to the refugees in that zone? Did they suffer more than the locals because they didn't have the social network, right? So this was one of the questions we investigated. I'm going to show you later a few results about that. But we can also do forecasting. Europe is always curious about how many refugees will come. Now that there is a war in Iran, how many people will arrive from Iran? We don't know. How many of them will be academics? How many of them will be less skilled? How much resource do we need? Okay, so if you want to do planning, you need data, you need forecasting. Even if it's bad forecasting, you still need it. The policymakers need it. Now, one of the things we looked at was mobile phone versus COVID. If you have a pandemic, mobile phones all of a sudden became extremely important. We can do contact tracing, we can do flows, hotspots, right? Key entry points, travel and interaction patterns. So you can actually tell me what happens if I shut down the flight network or the railroad network. How much mobility will I have? Of course, the problem is when you change things, people react and your predictions become sometimes useless. So Italy, for example, when they had COVID in north part of Italy, they shut down the railroad traffic and they said, we're quarantining the north of Italy. What happened? Everybody immediately hopped on their cars and went to south where there was no quarantine. So they actually brought the pandemic to the south and it was super fast. It just, it was a wildfire of pandemics in Italy. So the policy was extremely bad. Could they have anticipated it? Maybe yes, but it wasn't a data problem. It was what you do with the data. So when you do policy, our problem usually is we as computer science, I mean, how many of you are computer scientists here? Let me see hands. Not many. Okay. So it's for us that we're talking about. We're very reductionistic. We want to have a cost function and we flatten our task. COVID, okay. What is our cost function? The number of patients. That's what we want to minimize. Everything else is ignored in the model. Whereas social scientists know that it's a dynamic system. So many variables are connected to each other. You pull one thing, everything else follows, right? They have a more holistic view of the whole process. And they also know that there is a human factor here. And you have to talk to people. You have to see what's going to happen. Anyway. But we could do predictive analysis, cause and effect simulations, impact analysis. So COVID was one area where mobile phone data was super important and it was used basically in every country almost. So you asked about this call detail records. Here is how a call detail record looks like. You have a timestamp. Every time you make a phone call or you send a message, the database in your telco records one line of this. It records the time stamp, exact time of you making phone call, which base station or which telephone number is calling which other telephone number, which base station is connected to which other base station. Sometimes if this is another operator, we don't have anything here. Then you have a bunch of flags. You also have the call duration of the amount of data transferred. That could also be important for some of the analysis. Okay. And this is for voice messages. This is for voice conversations. This is for SMS. Very similar. Now, people have done a bunch of things on this kind of data. For example, you can look at the consumption patterns, call durations, number of events, lapse between events, reciprocated events. So I can actually tell which one of my customers is an extrovert, has a lot of friends, calling a lot of people, which ones are introverted, right? Maybe calling one person a week. I can also detect people who are calling their mother every day, right? No problem. It's in the data. I can also cover which accounts belong to bots and marketing firms because they place 1,000 calls a day. So I can filter them out from my analysis. I can look at the social network of my customers. I can determine their in and out degree, people that are important that receive a lot of phone calls, people who are active that call other people. I can detect that. I can look at unique calls per day, unique SMS messages per day. I can look at mobility. Radius of gyration, it means what is the space in which this customer is moving? Usually wealthy people have the means and they move in a larger area. Poor people do not have a lot of freedom. They move in a much smaller area. Now, when pandemic hit and the Turkish government introduced some sanctions, they said, you cannot go out between these hours or etc. One of the newspapers made a news story, said, oh, Levent and Etiler, these were very good, well-behaving areas. These people stayed at home. But look at Avcılar, bad people. You moved around a lot because they had access to mobile phone data. Of course, the problem was people in Avcılar, they couldn't stay home. They had to earn their daily living. They had to go to their work and make money. Whereas people in Levent and Etiler, they were more wealthy and they could afford to stay at home for a month, for example, doing nothing because they had the budget for that. So if you misinterpret the data, you can get very, very wrong results. Yes,
Data,
yes.
does that include things like WhatsApp or?
No. So, oh no, that doesn't. Because WhatsApp is data packages and it's end-to-end encrypted. You don't have that. So people are now using more and more voice over IP, internet, WhatsApp. That decreases the usefulness of actual mobile phone data because we don't actually use the mobile phone to call our friends. We use WhatsApp, and that doesn't show up in the CDR. Yes.
Yeah. The amount of MB or anything that is shared or sent or internet.
Yes, so this is called the extended data records. Your mobile phone company also keeps track of that because they bill you for that, right? How many data packages are sent. And this is more granular on the one hand, because you constantly exchange data packages with your mobile phone company. Even if it's a simple handshake, if it's a small package, you still have it. However, that data does not include your phone calls. So if you are, for example, active at a particular time of day and in a particular area, that does not show up very clearly in that kind of data. So it has advantages or your social network is not visible, for example. Yeah, so the CDR, I can build a network out of it. I can say, oh, this guy calls this other guy who calls this other guy. In XDR, I don't have that. I just have a data package. I don't know where it is going.
There is some kind of development, but can we have also this plan of the user, like this person's controlling this person?
Well, your telco knows it. If you can get it out of the telco, it's a different story. It could, it depends on how you deal with the telco. Normally, they don't share with you anything. Huh? I'm going to tell you about it a little bit. How to make your telco share data with you, that's something very challenging. Yeah. But we did actually get the data in one instance I'm going to talk about. So what are the advantages of the CDR? Well, it's a comprehensive data set, right? You're not constrained to the people who downloaded your application. You can access all people who are using Turkcell, for example. In some countries, it's pretty big. In Turkey, we have 3 telcos, each roughly having 30% of the market share. Turkcell is, I think, the biggest one, is a little bit larger than the others, but still all of them are around 30%. When the Data for Development Challenge was conducted in Ivory Coast, Orange Telecom did it. It's a French telco. They had 98% of the country's coverage. So they were able to really access almost everyone. The advantage is that you don't need a census study to learn things about the people if you can get the telco data, right? There is no explicit consent needed. You don't need to go to the people and say, can I use your mobile phone data, please? Because when you buy a telco line, it already says my data is, you can use my data anonymously for research purposes. You have already signed that, but anonymously, right? So I can use it anonymously, but not linking it to your, let's say, Turkish ID number. It's extremely granular. You get data from a mountain village in Ağrı, for example. Whereas if you were doing this with an application, or if you were conducting interviews, maybe, or surveys, maybe it would have been very difficult to access those people. The disadvantage is that the data is very difficult to obtain. You really need to beg the telco to give you this data. And maybe I will share you my experience, but it doesn't generalize, I think. It's very sensitive and it can lead to massive surveillance scenarios. So when we did the project on COVID, I published a small piece in SICSS about how to use mobile phone data for COVID. The Ministry of Health really liked it, and they called a meeting. They asked the representative of the three telcos, and a bureaucrat from the health ministry came and said, well, we want you to dump your CDR on our servers where we're going to link it with the Turkish ID numbers and do contact tracing. I was like, what? No, you cannot do that. First of all, there's an ethics review that you need to do. Plus, you need to anonymize, aggregate. They didn't invite me to the next meeting, but the thing is, if you have this data, you can say, all right, give me the names of everybody who attended the JHP meeting on that day, and the data is there. You can get that, right? Everything is there. You can ask, okay, I know that these dissenters are gathering here. Give me their names. It's there. You can get that. So it's very sensitive. And you don't want an authoritarian government to lay hands on this. But in some countries, they can do this legally. In Israel, for example, the government has a legal right to access the telco data because they have been constantly dealing with live terrorist attacks, bombs, etc. So for them, security is super important. For people, it's okay because they want their governments to know about this so that the government can protect them. In other countries, you have to fight that they don't have that. Consent is difficult to obtain if it is required. If you're going to process non-anonymous data, then the telco can actually send text messages to the individuals and say, we're doing this study. If you want to join it and gain 50 euros, please click on this link and then get explicit data donation from the customers. And then if you don't have that, it needs to be processed at an aggregate level. So the first big data set that was open to the public was the data for development in Ivory Coast. 5 million users, 1 year of data, antenna traffic. That means from every antenna, you know how many phone calls are being made, aggregated at an hourly basis. That's not a very sensitive data. So I tell you, Taksim Meydanı, okay, 1,200 calls between 1 o'clock and 2 o'clock. You cannot identify any person with this, but you can know at which hour Taksim Meydanı is very active. Is it an urban area? Is it an entertainment area? Is it an area where people come to work? You can determine these things. And you can also see where it is connected to. So where are these phone calls going to? Where are people going? If you know that a lot of people are calling Ankara near the Cumhurbaşkanlığı konutu, let's say, you know that there's something bureaucratic going on in that area. Then they also had 50,000 individual trajectories at antenna level. That means you put everything, all the phone records in a bag. You draw some of it, give them random numbers, and then you track them for a short amount of time, 10 days, 15 days. And you tell me which antennas is this phone making calls from. With that, you can know, for example, where does people who live here work, right? Because in the morning, before 9 o'clock, they make phone calls from their home. Between 9 and 5, they make phone calls from their work. So you can determine home and work locations and link them. And if I'm the municipality, I can say, oh, between Avcılar and Beykoz, there are a lot of traffic, but I don't have a bus line. Let me introduce a new bus line between Avcılar and Beykoz to solve this problem. It's super useful for the municipality. There are also 500,000 individual trajectories that is collected over the entire year. Now you can say things like, oh, this person was in Gaziantep for 6 months Then they moved to Istanbul and lived 6 months in Istanbul. All the phone calls have changed. So you can look at internal migration. You cannot do this with 15 days worth of data. You need at least a few months to determine whether a person has migrated or not. But of course, now the data becomes very sensitive, so you aggregate it to a higher level. You don't say this space station, you say this person is in Kadıköy. Well, a million other people is in Kadıköy, so it's not possible to single that person out anymore. This was very successful. I'm going to show you a few results. Then in 2013, they did a second challenge from Senegal. Then Bruno Lepri's team did a Telecom Italia challenge looking at CDR, electricity, weather, rain, news. So the data itself, the mobile phone data itself is not super useful on its own. You have to correlate it with some other stuff to really make it very useful, right? That depends on whatever your application is. Then Nuria Oliver was at that moment the chief research officer of Telefonica. She did a project in London metropolitan area, and then in 2018 I coordinated the Data for Refugees challenge in Turkey. I told you it was a collaboration between Boğaziçi, Türk Telekom, TÜBİTAK, and then UNHCR, IOM, and UNICEF, and a bunch of others. Then we did a Hummingbird was a European project that we conducted between 2019 and 2023. And there we collected data, CDR data from Turkcell. I'm going to give you a few results from that as well. And then there are a bunch of newer challenges. Any questions so far? How am I doing with respect to time? I'm roughly halfway through my slides. Is it too slow?
Up to you.
It's up to me. Okay. Are you bored? Just tell me when you're bored. We can do some exercise.
Maybe a support the blog thing.
You're determined to embarrass me today. That's what I can say. All right.
Halfway.
Okay, so I did already give you some information about the data for development. The interesting thing was that they didn't use the data themselves. They opened it as a challenge. And that's a beautiful thing because then a lot of other people come to the data with their own problems, right? 267 applications they have received, and they formed a special ethics committee to evaluate these one-page, two-page applications, and then they selected the groups that can receive the data. And we, in the Data for Refugees Challenge, we just mimicked them, right? They also established a special ethics committee who looked at possibilities with this data and then published like a guideline about how to do work with CDR data. And that report was invaluable for us. We just used it as well. They have mandated that the participants are going to destroy the data after the challenge. How many of you think that people actually destroyed the data? I'm sure nobody did. But the thing is, you cannot publish anything with the data anymore. So in my case, the Data for Refugees Challenge is the same. We ask the people to destroy the data. I'm sure it's in those laptops still. Every student has that. If they try to publish it, we will retract that publication. We will send an email to the editor-in-chief who will say, they cannot publish the data. So that publication will be retracted. Okay. Then another data challenge was organized in Senegal and Qatar. I told you about the data. Here's how we aggregate and anonymize the data. This was the research of Yves Alexandre de Montjoie, Cesar Hidalgo, and Vincent Blondel, who was at the time in Orange Telecom. So the original data tells you at what exact time a phone call is made from which base station, right? So 8:32 a.m., this base station, 9:15 a.m., this base station, 12:05, this base station. So now you know that this user is actually moving in this direction in the city. It's not perfect. So when you have these base station locations, what you see this here is a Voronoi tessellation. Anybody heard of Voronoi tessellations before? Yes. Can you tell us what they are? It's basically the collection of points that are closest to the base station, right? So if you have a base station here and another one here, the closest points, if you want to determine the closest points, basically there's going to be a line that goes right in the middle of them. All the points here will be closest to this one, all the points here will be closest to that one. And if you do this for all the base stations, you're going to, create something like this. Now, in your boundaries, these are infinite. So there will be huge areas, but of course they're out of the map, so no problem. In the cities, in urban, like Istanbul, for example, because you have a lot of base stations, your Voronoi cells will be very small. They're always convex and they're very small. But okay, so that's your granularity. I haven't put this slide, but in real life, when you have a base station and your CDR tells you the data is coming from this base station, the actual GPS location, somebody managed to measure that. They asked people for consent to share the base station and the GPS. They looked at where is the phone actually. And what they saw was the phone is basically in an area like this, right? So like a Gauss distribution. Yes, it's peaking here, but it's actually pretty broad. Because what happens is when this base station is very busy, a person's phone here is handled by this base station because these guys are actually pretty powerful. They can serve people quite far away from them. I mean, if you have ever been to the Ege region, you know that because your phone occasionally will connect to the Greek Jeep. And you know that Greece is quite far away, but it's no problem. These signals actually do travel quite far. So why is this important? Because all our inference in CDR is based on the assumption that we know the location of the user. We don't know it actually. We know the ballpark. So there is some uncertainty about that. Now this becomes important when you ask a question like, which hospitals do the Syrian refugees use in different parts of Istanbul? So you see, for example, in one part of Istanbul, all these refugees are going to this hospital. And in another part, they travel to a close by hospital. Maybe there's another hospital here. Why don't they go here and they go here? Any guess?
Expensive.
No. Language. There are no Arabic translators in this hospital, so they go to this one. So Kızılay actually did this research with the mobile phone data that we share, and they determined that some hospitals were underused, some mobile health centers were completely misplaced. Yes.
Know which data is from refugees and which.
I haven't told you that yet. Yes, I will. I will tell you that. Yes. Anyway, so how do we make this data more secure so that individuals cannot be tracked? Because maybe I've seen I can do a phone call here. So if I have a record that says 832 in my database, that must be there are not many people calling exactly in that time slot. So what I do is I aggregate it spatially and temporally. Instead of giving you the exact location, which I cannot do, I give you the base station area. If it's a very small cell, I merge it with the nearby cells, okay? And I give you only the time slot. I tell you the phone call was made between 8 a.m. and 9 a.m. So it's a 1 hour slot. Then there are 100,000 people doing phone calls, so you cannot actually determine who is what. Okay, so for the data for refugees challenge, we shared the cell tower locations. That became problematic later in the Hummingbird project because the government decided that the cell tower locations are sensitive. Why? Because now we had drone technology and you can actually have 6,000 drones taking out the base tower locations at the same time, completely crippling a country's communication infrastructure. If you know their exact location, you can send a drone with a bomb to that particular location. So now cell tower locations are sensitive information. We had to add some Gaussian noise on top of that so that the precise location is not shared, but it's out there. You can actually see the cell tower, so it's not exactly hidden, right? you can use a satellite image to precisely locate the cell towers. You can still do it. Anyway, we make it a little bit more difficult for people to take out the cell towers. We share the site-to-site antenna traffic, so which base station is communicating with which other base station for every hour. We do fine-grained mobility, 15 days for every user. We track you and we tell, we put into the database which base station, which time slot your phone calls are. And then we have the coarse-grained mobilities for the entire year, but now at the prefecture level. Now, the question of who is a refugee is a big question. And in the previous data sets, this kind of segregation is not done. There's only one record. But for us, it was important to understand what's happening to the refugees. So we said, okay, we're going to determine which phone belongs to a refugee by three things. If they have purchased the line with a Syrian passport, if they have managed to subscribe to the refugee tariff, which was subsidized by the government. So that means they were able to convince the mobile phone dealer at that location. Or if they have registered with a 98, 99, these identity numbers that the Turkish government gave to the Syrian refugees. None of these indicators are foolproof. They're all noisy. The Syrian consul is probably in our data set as a refugee. He's not a refugee, but he probably uses Syrian passport to get a line. Maybe you have convinced your buddy, who's your cousin, to sell you a Syrian tariff and at the reduced tariff, and you're completely Turkish. There is noise. But the good thing about computational social sciences, because we're looking at 1 million people, 2%, 3% noise, we don't care, because we don't care about individual points. We care about the larger picture. So if you try to identify individual mobility in the data set, you say, oh, there's a crime in this scene, and there is this user who has been here, and then he moved there. That doesn't work. You don't know what that user is, what that user is doing. You cannot do individual level analysis because it's noisy. You have to do higher level analysis. You have to look at groups of people. Okay, does that answer your question? About the Syrian refugees?
Yeah.
Okay. So far, there has been, yes?
So with those three criteria, is it any one of the three or all three?
Any one of them. Any one of them. And they have different proportions that we report in our explanation paper. Like when the paper where we explain the data set, we also report the proportion of, because there may be biases coming from these sources. Like what?
Like when I lived in Turkey, my residency permit said 99. They start with 99.
No, this is an identity number that the Turkish government gives you when you're a refugee. So it's not your phone's number, and it starts with 90. But it's not the phone number, it's the ID number. So they get something like a Turkish ID, but not with a Turkish ID number, but with a special number. Because with that, they get some benefits. They can have some milk, some like monthly payments. They get working permits, etc., etc. All kinds of things are done over this ID number.
Yeah.
So if you're registering for a phone line, you have to use this number or another country's passport. So this was as an indicator. Yes.
So the
Yes.
your personal number, where that's the AMR.
The noise there is, of course, yeah. Yes. So if you are an Afghan refugee, you also get the same number. So in our data set, we had also refugees from other countries. That was the noise in the 98, 99 bin. At that moment where we did the Data for Refugees challenge, we didn't have a lot of Afghan refugees. Later, when we did the Hummingbird project, we had indicators that was more granular. So we had one group for Syrians and one group for Afghans. Because at that time, we had 1 million Afghans by then. Yes.
Did you exclude the outliers? So where you actually know, oh, it's the content that I convinced to give me a
You could,
cheaper,
but
but you
I
didn't
haven't,
do-
well, I actually didn't analyze the data at all, like because I was busy with the administrative part of the challenge. So I didn't actually contribute in the challenge, but I haven't seen anybody do an outlier analysis.
Well, because you are dealing with big data outlier before.
So what would be an outlier precisely? Like, because you have behavioral data, and you could say, so there were people who filtered out phones that made 1,000 calls a day, for instance. You can say, okay, that's one way of dealing with some outliers. It's true, it's an outlier. But in terms of Syrian versus Turkish, there was no clear analysis that could separate the outliers that way.
give kind of more, if you look at all the patterns and you remove the outliers with such amount of data that
Yeah.
we're talking about, does it give you a better perspective, or doesn't it really matter? So does it give you more, how do you say, what's the English word for it? Does it give you more detailed information, or in this scale of data, does the outlier or the bots?
It may depend. It may depend on your research question. It may depend on how you define the outlier and what is actually an outlier in your case, right? So there may be.
Security office is more interested in outliers.
Yeah. So okay. Shall we give a 10 minutes break, by the way? It's almost an hour. So let's give a break, and I'll come and talk a bit more about the data for refugees. So the Data for Refugees Challenge was born because Türk Telekom wanted to do something for the refugees, right? And then it took me 6 months to convince them to do a data challenge. First, I went to their PR team because the data for development was organized by the PR team of the data for of the Orange Telecom. So I pitched them the idea. I showed them all the things that people have done with data for development. They loved the idea. They said, yeah, let's do this, etc. But then, of course, the PR team is the only team within the telco that benefits from a challenge like this. Everybody else is getting a lot of headaches. So then we went to the legal team. You're creating a lot of problems to the legal team because you're sharing sensitive data. We show them, okay, this is the user agreement that the data for development used in their challenge. We can start from this and adapt it. And that made their life much easier. Now, if you want to create a data challenge like this, GovLab in Washington keeps a repository of data challenge agreements, and you can actually get one of them and use it as a basis for your own challenge. That will simplify your legal legwork. Once the legal team decided that they can actually do this, we went to the technical team, because then they have to pull the data from the Hadoop servers. They have to write the scripts for that. They have to anonymize and aggregate the data within telco so that when it comes out of the telco, it's already aggregated. So even as the challenge organizer, I cannot individually locate anyone in the dataset. That's one of the conditions. They also agreed with our help that this is doable. And then we convinced the general management. They had a very progressive CEO at the time. Later, the team changed, and the new legal team said, "What did you do? How could you do this to us?" But it was already gone. So, but it took 6 months, yes. And at the time, I was blacklisted by TÜBİTAK because I was a signatory of the Academics for Peace Declaration. And TÜBİTAK was actually a partner in this challenge at the top level, right? The vice president of TÜBİTAK was involved. So every day I was expecting a call saying the challenge is terminated. It never came. And we managed to finish the challenge. It was very good that way. Anyway, so we collected 200 800,000 refugees and 800,000 non-refugees because you need a baseline as well. You want to compare them to the Turkish people. The data is noisy, as I said. Not all of them are refugees, but because you have such a large refugee basis, you can be sure that a large proportion of them are refugees. We set for this challenge 5 priority areas: safety and security, health, education, unemployment, and social integration. We asked people to write projects on these 5 priority areas for the refugees. And we said every project has to ultimately benefit the refugees. That's our main goal. So you cannot write a project that says, I'm going to develop an application for refugees, so I want to understand their demographics, etc. We wouldn't give you the data for that. We asked an agreement signed by individuals, not blanket, right? You cannot sign it as Boğaziçi University. Every person who is going to access the data has their name and signature on the agreement. That means people were implicated, legally implicated, individually. And that's important because you don't want blankets in this case. There was a committee formed to evaluate the proposals, but the committee would also look at the reports to make sure that there was nothing published in the reports that might harm the refugees. So we denied projects with obvious commercial interests. There were many projects that were well-intentioned, but had no technical background whatsoever. So primary school teachers applied with very good intentions, but absolutely no computer science background. They didn't get the data. We received projects from DARPA, from the Turkish Ministry of Defense. They didn't get the data. So any military link automatically disqualified the projects. There were a bunch of ethics issues we looked at. So first of all, the first important thing was consent. The data sharing should be permitted by the data owners. And that is in the legal agreement every phone line owner makes with the telecom. That states explicitly that the data can be used for research purposes in an anonymized fashion. So if you can make it possible that people cannot detect individuals in the data, then it's possible to do this. UNHCR, when they, yes, please.
So for the consent,
Yes.
I'm pretty sure that people always give consent.
Yes.
And most of them never actually read the terms.
Well, some of them do, but yes, you're right. They don't. So what you do is you think on their behalf. And we made sure that no individual could be harmed with this project. And I mean, 10 years after it, I can say that no one was harmed with this project. But you're right, you have to be proactive. And basically, our ethics committee also had refugee NGO representatives to make sure that the Syrian refugees had a voice on the decisions of who gets the data, who doesn't get the data, what gets published and what doesn't get published. UNHCR said no individuals should be tracked. Foreign countries should not be able to track individual refugees with this data. And we showed them this is how we aggregate, how we anonymize, and they were satisfied and they joined. IOM actually sent us a directive sent from the Ministry of Interior to the rectors in Turkey called a file that said top secret, saying all the refugee-related projects has to have Ministry of Interior approval in your universities. So IOM asked us, do you have this approval? We had no idea about that directive at the time. But we had the ethics committee, and the ethics committee had a representative from the Ministry of Interior on it. And when we said that, IOM said, okay, that's fine enough for us. And they joined the project. Now, normally, this kind of sensitive data has retention, destruction, and archiving clauses. So if you, for example, go to Google and tell them, please remove all my data from your service, they are legally obliged to do that. In our case, you cannot do that. Why? Because if you come to me and tell me remove me from your data, I cannot find you in my data. It's aggregated to such a level that it's impossible to identify you. You can go to the telco and ask them to remove you from the CDR. That's fine. But once we generate the data and it comes out, the mapping was destroyed. So there was no way of identifying the people unless you have the original data. The do no harm principle is actually a principle of medical ethics, right? It's a very old principle. We use that. So if you've in our data, you can see, for example, that the refugees are working in the construction site of the third airport, which is now open. At the time, it was still a construction site, and they were not supposed to. Or during the tourism season, Antalya municipality, the municipal said, refugees are not going to be able to work in Antalya during the tourism season. It's illegal work anyway, but we can see in the data that they are working there, right? We didn't allow people to report that because that might cause people to lose their jobs. So we don't want to harm them. Of course, they are working in very poor conditions. They're not insured. They're outside the system. Out of 3.5 million refugees, only 60,000 working permits were given. Today, it's around 100,000. It's still very bad. The number of refugees is reduced over the time, but they're still living in very poor conditions. They still need a lot of help. So access, correction, erasure, objection, we didn't give these rights because we couldn't do that, but it was found. Clear legal agreements. Every individual is individually responsible from them. Data protection by design and default is a very important principle. We aggregate the data during its collection phase. So even as the organizer, I don't have access to individual data. And that's by design and default. So as soon as the data is out, even if it is leaked, no harm will come because nobody will be identified in the data. And there is no blanket agreement. Okay, so we also wrote a bit of, a few papers about the ethics aspects and what we did and what were the considerations, and if you want to do it, how you should do it, or then we also screened the results. Results reporting direct mention of the ruling political party. So they looked at, for example, the votes of AKP in certain cities based on the refugee presence in that city, etc. We didn't allow them to publish that because it might have implications on the refugees in that city. Reports mentioning illegal work on certain areas, reports mentioning any third party explicitly, we didn't allow them to publish those. We asked them to anonymize the reports. Okay. So I'm going to show you a few things about what people did with CDR data, and I'm going to give you a mixture of data for development and data for refugees results. So this was, for example, modeling mobility. I think this is Senegal data. But what you create here is an origin-destination matrix. And today, the data I'm going to share with you will be in form of an origin-destination matrix. Basically, what you have is what is the source of mobility and what is the destination of the mobility. So these are all cities, and you can see from which city to which city people are moving. Okay? Why is this useful? Well, you can use this for a bunch of reasons. You can use it for improving the infrastructure. You can use it for sociological reasons, etc., etc. One project that was done by Koç University's Mire Koç, Ahmet İçduygu, and the big migration group there was the mobility of agricultural workers. So when there is a hazelnut harvest, the refugees had a blanket work permit. They could come and work at the hazelnut harvest. But nobody knew where they will come from, how long will they stay, when will they leave, okay? And in the data, we can see that. So this is the different months, January, February, March, and or the region. You can see the number of people increasing and decreasing. And you can look at the origin-destination matrix to see where they're coming from and when will they return. Another project, this was a collaboration between Sabancı University, Selim Balcısoy Group, and MIT. They worked in the past with Alex Pentland's group. This was, I think, one of the best papers. They looked at social integration. they derived a bunch of indicators for each city. One of the indicators was relative refugee to local calls. So how many calls are placed from Syrians to Turks versus Syrian to Syrians in every city? Another indicator was local encounter index. Which base stations had a mixed reception of Syrians and Turks? So do these people see each other, right? Then they had another one that was a spatial integration genie, and then employment scores, and they kind of combined the different scores, some of them coming from real estate data, other data sources, and they create a single index. And according to their index, for example, Urfa was the worst integration city. And this was 2017 data. In 2018, there were refugees killed in Urfa during encounters. So, it was actually pretty decent index. And of course, you can build policy on that, right? You can say, oh, in these cities, refugee integration is very bad. So what can I do? Maybe you can organize events that will bring people together, create public spaces where these two communities will interface, etc. Another project that I mentioned to you, this was done by Turkish Kızılay, the Red Cross. The colors show you the refugee concentration in Istanbul, and the red dots are the mobile health centers. So you can immediately see that in this area, there are a lot of refugees, but there's no mobile health center nearby. Whereas in this area, there are very few refugees, but there is a mobile health center. So a naive approach to policy might be, oh, I'll take this and put it here. But policy doesn't work that way. Maybe there's a hospital that supplies the doctors to that mobile health center, and moving this to this area is very, very difficult because this is a very densely populated area. There's no space, right? But at least this gives you an idea, and then you can diagnose what's happening and you can improve things. But if this is going to go to policy, you make sure that you take into account a much broader set of indicators. This was an Italian group looking at measles. So the Turkish people were mostly vaccinated against measles, whereas a majority of Syrians were not. So what if a measles pandemic breaks out in the refugee population? How will it spread? They did a simulation study, and they showed that in the cities there was good social integration. The Turkish people created a buffer, and the measles would spread much slower. Whereas if you had a lot of segregated refugee populations in cities, a potential measles outbreak could be very deadly. It would rapidly grow out of hand. So this is very useful information. And this was pre-COVID. So the insights we gained from these kind of things actually served us very much in the COVID. Mobility on special days, like for example, what happens in Kurban Bayramı, okay, Şeker Bayramı, national holidays, where do people go? Now, this is one potential data set or result that can harm refugees. If you can show the Syrians are going back to their countries in holidays, in some countries, this is enough to drop their refugee status. If the government may say, if your country is safe enough for you to return on your holidays, then you don't really need the refugee status. So you have to be careful when publishing these kind of things. People's behavior during emergencies. This was, again, the Senegal data. When there was a big flooding, where did the people go? So from the emergency areas, which other parts of the country did they move? Because now you need to make room for them. You need to bring resources to these other locations for these newly moving people. This was Didem's master thesis back in the day. It was published in 2016. This was countrywide arrhythmia, basically emergency event detection. Now, this is one base station, and you can see the activity of the base station is like a heartbeat. During day, it's increasing. At night, it's dropping, right? So it's like a pulse. And then on some days, you see that there's a huge peak. Now, if your national team is scoring on that moment, you will see this peak across the entire country. But if somebody is shooting someone on the street, which was the case in this data point, you will see only activity on that base station. The problem is, how do you interpret this, right? So in our case, we looked at newspapers from Ivory Coast for the next day and used Google Translators, things like that, to understand what might have happened. And for some peaks, we were able to find what happened. For some, we still don't know what happened, but something happened, obviously. But our contribution was a Markov-Poisson process to basically detect these anomalies in a pulse-like temporal time series data. Now, when we did the data for refugees, I was suspicious that eventually the telecom will realize what they have done and say, we're going to remove everything. No, this shouldn't have been out there. So I made sure that they can't do it. We published a book with the report. So it's open, I think. So you can just download all the reports. Actually, if you go to my webpage, all the project reports are still there to download. That they cannot remove. Anyway. We also, at the end of the project, we had a closing workshop where we invited policymakers, TÜBİTAK, governmental organizations, because ultimately we wanted the project results to reach the government, right? That was our main idea. And we tried to write a white paper, policy paper, for them. So in the workshop, we divided the participants into 5 groups. Every group was led by a senior scientist, and they worked on their topic of the report for an hour, for 2 hours, and then they went home and they collaborated over internet. They worked for another month, and then a big policy paper was written. So that is also in the book. And did it change something for the refugees? I really don't know. Policy is not my field. I don't know how to measure this. Maybe it did, but we did our best. But if you really want to change things, you really need to follow it up and push the projects that have really high impact. So one of the things that we discussed was, for example, the language centers. The government initially created language centers for the refugees to learn Turkish language so that they can contribute to economics. The students, the children can go to Turkish schools eventually by learning Turkish. But then, of course, the people who go to these schools are only Syrians, right? There are no Turkish people going to these mobile or small language centers. And that was negative for the social integration of the kids. And they decided that it would be better to send the kids to ordinary schools. And they did that. The problem is these language centers, the mothers were also going there, and they could then also contribute to the family economics because they learn Turkish much faster, etc. When they did it, when they moved it to primary schools, the mothers could not attend. So a decision that ignored the mothers actually was a bad policy idea. Now, if you're really immersed in the situation, you know these things and you can influence policy. But from the data, you cannot read these. You really need to be there. So ideally, and this is true for any computational social science, you have to work with people who are on the field. You have to work with social scientists who have the insights, because the data will paint you a completely flattened picture of certain things. It will hide all the complexities. It will give you only what you have measured, but the situation is usually much more complex. If you're working on mobile data for Venezuelans, maybe you want to see their mobility into Colombia. There were a lot of Venezuelans going there. If you don't know that mobile phone sharing is a thing there, you will completely misinterpret your data. Actually, every phone line is used by 15 people there because the phones are expensive and they don't have the money to buy it. So they have cards that the phone circulates around the people. So if you don't know it, your interpretation will be bullshit. So you have to really understand. Okay, so Data for Refugees project ended that way. We wrote our white paper and we tried to reach the policy people. I don't know what happened. But after that, we did the Hummingbird Project. So with Tuğba Bircan as the PI. And that was broader than mobile phone. That was about using all the big data sources, satellite imaging, social media for migration and mobility. My work package was the mobile phone, but in this case, we worked with Turkcell. And now we had flags not just for Syrians, but also for Afghans or other Turkic republics in Russia, Turkmenistan, Azerbaijan, Uzbekistan, because they send a lot of people to Turkey as well. Okay. We collected a large data set. We had, again, a refugee flag. We had residential addresses. We had 4 different groups. And then we looked at a bunch of things. So this is, for example, fine-grained refugee analysis in Istanbul. You can see where the refugees are at prefecture level and actually higher granularity in Istanbul at 100 by 100 meter grids. We also look at land use, land cover, and nightlight state. So we basically do a multimodal analysis. Now, one of the interesting applications we did with this data was when Erdogan opened the border to Greece in March 2020. He said, I'm releasing the Syrian refugees to Europe. Now you'll deal with them. And a lot of people went to the border. We could actually see who went to the border and from where. And they were not the Syrians. Most of them were Turks. And the sociologists told us that most of these people were the Gülen supporters who actually had a civil death in Turkey. So they were completely removed from the social system and they had to go to Europe, basically, or elsewhere to survive. But we could see who disappears from our data and who comes back to when the border was closed again. Another interesting analysis we did was after the earthquake. We wanted to make sure, we asked the question, what happened to the refugees in that area in the earthquake? And there we worked with Didem Danış and Cemil Yıldızcan and Galatasaray University sociologists who actually went and talked to the Syrians in Hatay on the field. But we could see the hotspots of mobility where they moved to. And we saw that the Syrians had much limited mobility options after the earthquake. A lot of them had to go to the refugee camps and stayed there for months at end. Whereas the Turks, they had family, relative relations elsewhere, and they were able to go to other cities. Now, sometimes your data will paint you a different picture than the official data. So I told you about the telco airtime top-up data. This is data from DT1. This is Italy, map of Italy. And this is the normalized migrant stocks from the official numbers, Cameroonian migrants in Italy. You can see that there are some areas where the Cameroonian migrants are supposed to be, according to the real data, the official data. But when we look at mobile transfers, so who sends mobile remittances to Cameroon from Italy, we can see, for example, a lot of activity from Sicily, which doesn't show up in the official data. So we know that there are a lot of Cameroonian migrants at this point in this area, which does not show up. So they're not registered in Sicily, basically. So this kind of data can give you real-time insights, and you can actually base policy decisions on that, but you have to kind of carefully anonymize and aggregate. So we also wrote a book from the Hummingbird Project, and it's actually a textbook about how to use data, big data for migration and mobility. That's also available. Now we're looking, at the moment, we have a project on empowering citizens through transparent decision-making. And we look at social media data, for example, and mobility, academic mobility, for example, is at the moment in our focus, especially now that Europe wants to retain researchers, research power, and they want to attract researchers from US because the political situation in US is very anti-academic at the moment. So Europe is trying to get the researchers and retain them. I will, when my talk is finished, I will give you a data set from this challenge, human mobility challenge. It's not a CDR, it's not raw CDR, but it's an origin destination matrix from human mobility recovery after the Noto Peninsula earthquake in Japan. So this was an earthquake in 2024, and you will have data from before and after the earthquake, and you will try to predict how people have moved back to the area after the earthquake. So the origin destination matrix is, so the whole area is divided into cells. So XY coordinates a grid, and from each grid cell to each grid cell, you will get an origin destination mobility flow. So I'm curious what you will be able to do with that. So it was quite an extent. I mean, we all hear that, oh, huge earthquake in Japan, only 2 people died. But of course, it's a huge earthquake zone, and there are very devastating earthquakes, also typhoons, for example, and other natural disasters that sometimes hit and damage the cities. I'll stop here. This is my email address. So after today, if you have any questions, etc., you can always send me an email and keep in touch. And if you want to actually join the challenge as a team, me and Bilge will be happy to supervise you a bit and exchange ideas, and we can continue the conversation. Thank you very much. So, any questions, comments? Yes. Yeah, of course. You already asked. Okay, fair enough. Okay.
I was very inspired by this stuff. I was just wondering, the CDR records, how about E6? So, or is it only kind of like the traditional, how does that work?
How about one?
So you have these eSIM, so through PayPal.
Okay. Yeah. Yeah.
Or is.
So if you have an eSIM, the company that provides that will have the CDR.
Okay.
So every company has data about their own customers. And this data is so voluminous that they don't keep it indefinitely, right? Or at least they tell us that they don't keep it. Maybe they do. But XDR is much more voluminous, obviously. So Turkcell was keeping the XDR for a year, about a year. They also don't know what to do with it, right? I mean, the last portion of it obviously is useful for CRM, but the historical data, they don't have any usage for it because they don't do sociological or historical analysis. They don't do that. But if you have that, it's super valuable because it shows you how cities have changed, how different areas have grown up, how the purpose of a portion of a city changed over time. It can give us a lot of insight, but they don't care about those things. They're just after selling their customers some services. Yes.
Like purchase the data from Turkcell or like.
We didn't know. So in Türk Telekom, actually Türk Telekom not only did this for free, they also provided money for the winners of the 5 areas in the challenge. So they did it completely pro bono. So that's a very good example of a data collaborative. Turkcell received a little budget from the Hummingbird Project, something like 50K. It covered a little bit of their effort. Maybe they actually spend more effort. But in Turkey, every telco has to have a research and development center that's mandated. So they have to do projects. And the super weird thing is they will come to universities and ask professors to do projects with them. And when you ask them, okay, what do you want us to do? They're like, we don't care. Do whatever you want because we want this for tax benefits. We don't really care of developing anything. As long as we're doing RD, the government keeps renewing our telco license and gives us tax benefits. And that's way more than whatever peanuts we're paying you. So it's sometimes 2 minuses make a plus, but yeah. Okay, yes, please.
I will make it
when we will have our lunch, but embarrassing more, maybe I can talk here. I know you from your support to profs still in here, and when you said that I don't want to leave no one
Behind, yeah,
behind.
yeah.
Really important. And I was wondering your work a lot, so it's a pleasure to actually hear you.
Thank you. But I was very disappointed at the end because I was expecting the government to be more interested in the data, to do projects with us. But unfortunately, many of the governmental agencies did not have the capacity to do things. The people who came from these governmental agencies to take part in the committees, etc., they did not have the credentials. It was very disappointing that way, but yeah. Yes. Yes.
So I'm Dutch.
Okay.
And I'm a faculty and actually, probably you know, the migration debate is
Yes.
quite heavy.
Yes.
I am wondering how is the Dutch government in comparison to the Turkish government, are they more invested?
Different world. So actually, the Ministry of uh, Migration and Ministry of Justice, etc., they come to us and they ask us our opinion, and they do projects and they invite us as experts to these projects. So I, for example, was a coach to one of the projects about big data sources on irregular migration. And the Ministry of Justice has this branch called VODC, and I work with them. And a couple of weeks ago, they organized a yearly conference called the State of the Art Conference, where the minister also comes. And a lot of researchers, we attend that, and then there is a discussion platform. We also had a project on the mobile phone screening procedure. So there was this Athena project that the Dutch police was prototyping. Basically, when you apply for a mobile phone, when you apply for asylum, the government will take your mobile phone and investigate whether it has certain content on it. For example, do you have pictures of radical Islamist settings, or do you have pictures of weapons on your phone? Now, there was some parliamentary inquiries, and we basically talked to a lot of people from the ministries and from the IND, from Marechaussee, etc., to understand how the process works, what are the steps, what is the involvement of AI in this process, what kind of biases might enter the process at what stage, and how does the data live in governmental institutions after the process. So you give your data to IND, but that data travels, and nobody knows exactly where it travels, who has sovereignty over this data, when is it erased from the governmental servers. And then we wrote a bunch of papers, but also Koen Lers from the Utrecht University gave a bunch of interviews to Volkskrant, etc. And it actually made policy implications. So the government took some steps back and they shut down the prototype and are now much more careful. So in Turkey, this is much more difficult, influencing the government that way. When you want to do that, there are other ways. You know, if you know someone that knows someone, maybe you can tell them and may influence the policy. But in the Netherlands, there are much more formal channels to do that, which is, for me, it's a beautiful thing. And I'm really glad that they're able to do this. And they're also always open to dialogue. Yeah.
How is that? Because Europe now has the terrible sending back cuts.
Yes.
So is there something that you're thinking about around that project and the data that you have, and see how that kind of evolves, or because I think there is a lot of mistakes.
Yeah. So in Utrecht, we have a so in Utrecht University there are focus areas. Those are across the university, so they basically make available some budget to organize things across faculties. And one of the focus areas I'm in the steering board of is migration and societal change. And this basically brings together people from sociology, law, computer science, not much, I think I'm the only one, but you get the picture. So a bunch of people looking at migration from different lenses. Now, when we realized that reaching the government and changing things is difficult, we set up a small group and we invited people who have expertise on that. Like, how do we make the results of our science more accessible or more palatable to policymakers? How do we talk to the press? When do we talk to the press? How do we frame our results so that it can be published by the press and makes, let's say, an impact? So how do we close the impact loop? So a free press is extremely important. And I'm happy to say that in the Netherlands, it works better. But going through the press is a very important device. Going through the legal system is another thing that you have on your hands. And practically, you have to do all of them. If you want to get impact, you also need to talk to IGOs and NGOs who have a different kind of awareness raising capability and have move in different circles than you. So you have to attack the problem on all possible fronts. Of course, you don't have the energy to do it all. So you need to bring the people in a room, you have to discuss it, and you have to send them home with a mission. That was our aim also with the policy workshop that we did at the end of the data for refugees. And some of these resulted in other projects. For example, the Hummingbird Project could really easily get the data from Turkcell because Turkcell told us, well, if Türk Telekom did it, we can do it too. So data for refugees served as a nice template to initiate another project. Now, I don't know how many of you work for companies, but if you're working for a private company, you can be a data steward and you can open your company's data to a public institution that can do something useful with it. And you can think about how to do this without harming the company. You can monetize it, you can sell it even, so that it becomes sustainable. Because if there is no money involved, the company will be demotivated to continue this. But one thing that we're constantly pushing the telcos for is to create a platform for earthquake management. There will be an Istanbul earthquake. We know 1 million people will die, more people will die, and this needs to be managed. Now, if we have a system already in place that when an earthquake happens, somebody pushes a button and the data starts flowing to the ministries in an aggregated, anonymized fashion, maybe already all the scripts are written to manage the humanitarian response. So that will be super, super useful. But we need to really incentivize the telcos to do that. They need to get the money to develop this infrastructure. We need to do the legal groundwork. It takes 6 months with the legal team to formulate a proper legal agreement. You cannot do this in the humanitarian context because you don't have time. You have to immediately intervene. So all this has to be done beforehand. And that's preparedness, basically. Yeah, so some of the research done in this area is about estimating the number of people in earthquake reserve sites. After the earthquake, you look at the phone call data and you say, okay, we reserved these spaces. Now there are people in these spaces. We need to bring them food, water, resources. We need to evacuate them to these other areas. No, this is, you can do forecasting before, but during the earthquake, it's near real-time data. So in Japan, for example, the telco has a collaboration with the ministries and they can actually look at it at real time. Yeah, or at least you can show that this is how you manage this. Yeah. Okay.
With this, yeah, with this real-time data, actually, I think we can predict the election winner, or like predict the protests. As even we can use maybe some AI agents to monitor these sort of social movements on them.
Yeah, so
People are
predicting elections can be done by many different things, right? So there is this famous research by Alexander Todorov from, I think he's in Princeton. He works on face analysis and psychology. He's in psychology department. So he takes the candidate pictures of the local elections in the US. He goes to a village in France and he asks the people, would you trust your kid with this guy for the weekend to take care of him? He's able to predict the election outcomes with 75% accuracy because we don't know the CV of the candidate. We just vote for the face sometimes. Stereotype judgments. Now in Turkey, it's different. We don't care about the candidates, we vote for the party. Because in Turkey, no candidate behaves independently from party politics. So there has been no instance where, let's say, a CHP parliamentary voted against a CHP proposal. Whereas in a true democracy, of course, each parliamentary should be individually deciding on what to do. But this is not the case. Turkey is not a real democracy in that sense. They're all block voting. That means if you have the majority, there's always the party politics will just continue, which is a missed opportunity to say the very least. Yeah. Yeah, but you can predict some of these things. But they're also extremely short. Like one day before the election, you do something and it has implications. When Adnan Menderes came into power in Turkey, there was a radio broadcast saying he won. So a lot of Inönü supporters didn't vote. They thought the election was already lost. And that changed the outcomes. That kind of manipulation, that was 1950, I think, something like that. But it's always there. It's not just social media. It's normal media as well. Now, if you have the government controlling the majority of the newspapers and the TV channels, and now the social media through a link with Trump to Musk, and now AKP is able to block a lot of Twitter accounts because of this link. I think it's provided as a service to them in return of I don't know what. That's a huge power. That's a huge manipulation power, and they use it. We see the results in the past weeks. So many accounts were blocked. LGBT accounts are blocked, center accounts are blocked, leftist accounts are blocked in Turkey. So you have to think around it, but it's very difficult. Yes?
I would like to say special thanks to you because now that we are in Boğaziçi University, which is in the middle of an institutional crisis for a period of time, and you as a scholar who is a part of the academics for peace community and working on migration, I think what you do is really valuable, and I'd like to express my gratitude
Thank you.
and solidarity.
Thank you.
Thank you.
I left Boğaziçi before all of these things started. I mean, I went to Japan for a sabbatical in 2017. Melih Bulut came afterwards. But it's really, of course, it's really sad to see everything that has been happening here. And as Kavafis said, you take the city with you when you go. It comes with you. I've been a part of this institution since '94. Every time the library was the favorite place of my life. For me, it's home. And it breaks my heart to see it that way. But we don't have a lot of power to change it, right? Because people don't care. People still think that this is an elite institution, and they work that angle as well, so that people do not support it so much. They're like, oh, but you didn't do anything when other institutions were in danger. Actually, we did, but who cares, right? It's all misinformation. But yeah, thank you. Okay. So shall we try to make the data set available now? Are we going to lunch, or I don't know, what time is it?
Both.
Well, both. All right. So let me stop sharing.